Welcome one and all to the second episode of the second series of D&D with Mike.
And with Zoe.
And today we're going to keep on working on our locomotion. The first thing that we're going to look into is fixing the fact that our timer for can jump doesn't stay off for enough time. So here you see can jump should go off as soon as I jump, but it doesn't. But if we then check it in the air, it does work. You saw it there, right?
Yeah.
The reason why this is happening is because the raycast results true in a few frames, who knows how many, at the beginning of the jump. So what we're going to do is we're going to turn off raycasting down for the duration of our wait. Okay? Now this may cause us problems later. We'll see. So let's begin with that. Let's take a look at our thing. Here you go. Can jump false, can jump true, right? But can jump turns to true as soon as we are grounded, I betcha. Ground ray, ground true, stop jump delay. There it is, right? So we stop the jump delay. What we should do is actually remove this, now that I think about it. And so we're going to turn this off, I think. This may be a wrong idea, but a bad idea, but we'll see. And what we're going to do instead is we're going to say if can jump, check grounded. Okay? So where do we put it? In here or in here? Let's do it here. So go if can jump, close round, open squiggly. Oh, wait a moment. No, this is going to be a bad idea. Save. I think this may actually already work because we're not stopping the delay. So let's try. I don't know if there's going to be a conflict between the grounded boolean and the other one. I hope not. Well, let's try. Okay. Are you pressing any keys?
No.
Why is my click not working? It's supposed to be working. Okay. So I think I broke it completely. It's not jumping at all. Yeah, the character's not jumping. Oh boy. Alright, so let's restore what we had. Stop jump delay. So perhaps the problem was that can jump was false. That would make sense because by default it'll start on false. Yeah, we need this. We absolutely do. But we need to do something to delay this check grounded. Like it cannot happen, or at least it cannot have the same effect. How? We could do a just jumped and then turn it to false. But as you can see, they look the same, but logically speaking, it would be a little bit different. Yes, so let's create a bool, which we're going to call just jumped.
Okay.
Make it private here. Private bool just jumped. Jumped. Yeah. Save. Copy. And blah blah blah. Start jump delay. So start jump delay. Put this one as useless. Put it here. Paste equals true. True. Semicolon. And
oops, sorry. I pressed Control V.
And here turn it to false. Paste equals false. And now we're gonna use semicolon. Save. Now here we're gonna check if not just jumped. So you go if not just jumped. Yeah, close, open, wait, close, save. Okay, so if not just jumped, do the thing. Good. Let's see. I think this will work. Okay, we can definitely jump. Look if it goes false. Yes, it does. So if I click twice, the second jump didn't count. Then I clicked again. Let's make our audience here. So click, didn't happen, right? Because my second click was inside that window in which can jump was false, right? But if I click again, so if I basically hammer it, you'll see that it does it late or late-ish. Certainly later than doing it too fast, and then it simply doesn't work, right? Whereas now it's working fairly well. See, it always does the second jump. At any rate, we are definitely going to do all sorts of tricks to make it look more oomphy and cooler. Okay, so for now this is good. Now what we are going to do is we are going to play around with gravity. I really don't like how floaty this feels. Like it feels like I'm the moon, right? So an easy fix, you would think, would be double the gravity. And it's definitely better in terms of how fast we fall. But we've got an issue. It's affecting all of our jumps, right? So what we are going to do, dear, is we are going to apply a curve on our jump, on our gravity effects. Okay. And so there will be like some kind of coroutine, just like this one, jump delay routine or something, that is going to manage our gravity. And it's going to start with gravity being 0, and then rapidly increasing, and then dropping. We'll see how, right? So let's begin with that. For that, where's our gravity? We're gonna need serialized field, private animation curve,
Whoops.
Wrong key.
Wrong key.
Animation curve. Yeah. And call it curve underscore jump gravity. Jump gravity. Semicolon. Save. Okay. Now we're also going to need another serialized field. It's going to be a private float. Let's call this one gravity curve duration, and give it a value of 0.5. So equals 0.5 f. Yeah, save. So this is how long it will take for that curve to reach its conclusion. Okay. And we are going to create another coroutine for this one. So here go private coroutine. Coroutine core underscore jump gravity. Semicolon. Save. All right. Let's make the I enumerator now. I enumerator, jump gravity routine. I've never done this before, so this should be interesting. Routine. All right. Open, close. Nope. That's a call. Yeah. Okay. Save. So. And by the way, for the air one, we should probably do it differently. Yeah, let's put a bool here. Go bool air equals false. Sure. Save. Okay. So every time we jump, and we jump validly, so we do start jump delay, we're actually gonna rename this from start jump delay to start jump routine. So hit Control R twice. Routine. Yeah, hit enter. Now instead for stop jump delay, we're going to leave it like that because it's specific to the jump delay. Okay. Whereas this guy here is also going to be managed by this. So here you're going to say if open core underscore jump gravity is not null. Stop coroutine core jump gravity. jump gravity routine. No, sorry, core jump gravity, my bad. 2 down. Close. Semicolon. And now we're gonna start it. So core jump gravity equals, there it is, equals start coroutine. There it is. Open round, jump gravity routine. Yep, open around, and we're missing a bool. So copy this, paste it here. We'll paste it.
Sorry.
Paste it. Oh, okay, copy again. Paste it. All right, and we're gonna remove this, and here feed it air. Close round again, semicolon. Save. Now our jump routine may start requesting us whether we want in the air jump or not, and which one is in the air. This one is grounded, therefore this one is on the ground, so this stays false. But this one's in the air, so put a true. I'm actually going to change my mind on this optional, and I'm going to remove it, so it's required. Put a false here. So we always know what we're doing. Save. Okay, so that's done. Now here we're going to create our very own favorite float passing time equals 0. F, yeah. And you're going to create a while loop while passing time lower equals actually. Lower equals to 1. Okay, now passing time plus equals time dot delta time divided by duration. Dot delta time divided by duration. Whatever we call it. Duration, I'm fairly sure. There it is. 1 down. Semicolon. Now do a yield return. New wait for seconds time dot delta time. Yield return. New wait for seconds time dot delta time. New wait for seconds time dot delta time. It's fine. It'll fix itself. Ting. Time dot delta time. You're all serious today. Is it tired?
Yeah.
Close the
Quite.
round. What?
Yeah, quite, I said.
Quite. That's dramatic. Okay, put a winky face. No, that's it's a normal
Save.
face. Save. Okay, now what we need to do is we need to lerp using that curve, right? So gravity is going to start at 0 and then go to whatever value it has. Okay, actually, that's going to be a problem because we need to remember the gravity, our target gravity, so to speak. So we are going to say float target gravity equals gravity. Oh, that's a bad idea. Wait a moment. That's a bad idea. We need something else. We need a new variable called current gravity, which is going to be private. So yeah, create a private float current gravity. Yeah, semicolon. Save. All right. And wherever we use gravity, we need to change that and put current gravity instead. So copy this, paste it here, save. Okay. So one thing we need to do right away and start at this time is paste equals gravity. There it is. Semicolon. Right. So save. So it's gonna have that value. Okay, and then here we can change the value of current gravity, and whenever we're done, we restart it back to gravity. So we're going to say current gravity equals mathf.lerp open round, and the starting point is, what's the lowest point?
0.
0. So we're going to put 0f, and the highest?
One.
No, that makes no sense. The highest point is our value for gravity. This one. This is a stored value. We're never going to change it, okay? We just keep it. And this one is a value that changes all the time. So this is our top goal.
Oh,
right?
okay.
So gravity, comma,
passing time.
and no,
With the curve.
too easy. So curve, curve, that's the one. Dot evaluate,
passing time.
open round, passing time. Close round, semicolon. Save. All right. So now our gravity is going to change all the time, every time we jump. And it's going to like disappear and then reappear in all of its might. Well, it depends on our curve. So let's go and set up this curve. Curve. Player. He's got a curve now. Let's put the gravity on 30. No, 30 was probably too much. Let's do 25, right? Okay, and now the curve. There it is. So for now we're gonna make, say, easy and ease out. So, let's see. See how this feels.
Doesn't feel like the moon anymore.
It feels very different though. You can definitely see the trajectory traced by the jump is totally different. Okay, so the curve duration is 0.5. Let's try a different curve, like fast acceleration of gravity. Let's try the opposite. Let's try slow acceleration of gravity. See? That feels to me a little bit like the original Mario, but we need more drop. We need faster drop. So let's go 50. Let's go insane. Boom. Right. So right now we don't have anything that allows us to hold the button, which I think we should put at some point. But we can do crazy things, you know, here. We can do like weird curves.
Look at those weirdos.
Well, these wouldn't work because they go back down. We need something that goes up.
Like these ones don't go up. But...
We need something that goes up, then stands still, then goes up again. So let's take, for example, this one. Okay, create a new point.
Wow.
And do this. So we're gonna have half gravity for a bit. There. Yeah, feels pretty good. It's a bit fast on the fall, and our jump strength is suffering for it. What do you think?
I think it should go a little higher.
Okay, so let's give a little bit of more jump strength. Maybe that'll help.
Yeah, that's good enough.
So how does this jump feel?
It looks good enough.
Certainly looks better than before.
Mm-hmm. Before it was like the moon.
Yeah, I'm not too happy about that little bounce that happens when you reach the ground. It doesn't always happen. The problem is the physics updates are relatively rare. We'll see what we'll do about that. Yeah, but it seems to be working fine. You give it a try, see how it feels in your hands.
Well, I think I found a problem somewhere.
Where?
Close. I think I just pressed it too fast.
I think so. So it didn't trigger. Because you have so little feedback from your character, it's now quite difficult to sort of notice when these things happen. Yeah, we can always jump delay a little bit longer if we wanted to. So we don't allow the second jump by, say, 0.7. Try this. Yeah, that seems to me too late. Let's try 0.5. There. So try and do double jumps. Yeah, that looks perfect. Yeah, that looks pretty good. I like 0.5.
Mm-hmm.
So what do you think about the whole trajectory? Still not good enough?
I think it's good.
Well, let's give it a few more tries. Let's try a quick acceleration of downfall.
Okay.
There, let's try that. Oh, I like that you fall fast. That's cool.
Yeah.
No, wait, but that looked weird.
Yeah, it's getting really short.
Let me borrow this.
Yeah.
Okay. So, no, yeah. Ooh, I think I missed it. I think I missed the second jump. I think 0.5 may be slightly too much. Let's try 45. So, yeah, so I'm expecting it to happen at the apex. You know what? We'll probably change it a little bit. We're gonna do something else. So for now we just have a very simple delay. What surprises me is that the second jump doesn't feel strong enough. Oh, because the second air jump strength is weak. And it's still as weak as before. Let's try and boost it a little bit, so to 12. Alright, that's a little bit more oomphy. Uh-oh. Yeah, to me that delay feels too slow. No. Not always, but sometimes. So I'm gonna go back to 0.4. It's very hard to make these decisions. We should do something clever, like for example decide when to allow double jump when you've reached your apex, for instance. Or when you're close to reaching your apex. But that comes with all sorts of extra possible errors. This doesn't seem too bad. Yeah. Yeah, I think this is fine. Whee! Bonk. Alright, good. So yeah, guys, it takes quite a while to make these decisions because it's about game feel, and that's a difficult one to crack. What I like, you may not. What my daughter likes, I may not, and so on. So it becomes a bit of a mess. Okie dokie, what are you doing with your glasses? Do you need to clean them?
Yeah.
Alright. Dirty glasses emergency. Daddy to the rescue.
What are we gonna do next?
I'm the lamest superhero there ever was. I clean glasses, that's what I do. What are we gonna do next? First of all, we're gonna save these settings because they seem fairly good to me. So we're gonna do copy component. And now we're going to stop this. Beep. And we're gonna say paste component values. There we go. Okay, that's looking good. Big save. All right, so the next bit would be to worry about our wall grabbing problem that we've got. And that must be happening because of our collision. Okay. So the issue with collision, yeah, I'm thinking. The issue with collision is that we're managing collision using the actual colliders, and we may want to start not doing that. Of course, that will come along with a lot more pain because we're going to have to worry about colliding everywhere, up, down, left, right, etc. So perhaps for now we should go with a slightly cheaper thing, which is creating some kind of raycasting system horizontally that points in the direction we're going. And if they hit something, we reduce the possible amount of push that you do on the stick. So let's try and do that. Let's do Control MO for now. All right, so for this one, similar to these rays, we're going to copy all of this. Actually, this may be too much. Copy these three.
Oops, that was paste.
Yeah, I can see that. Undo. Undo. Okay, copy. Yeah, can you do it with two hands, or are you too lazy for that?
Oh, wait.
Paste. Okay, so we're going to need an array of rays, and we're going to call this side rays. Side rays. I don't know if we need multiple ones, but do we need multiple ones? I don't think so, but it may be useful. I'm not sure. Sure, let's make multiple ones for now. Okay, so side hits. Hits. Save. Okay, now side ray length. Fairly sure this is too long, but don't worry about it. It's already there. Banana. Save. Okay, now what we're also going to need for these guys is origin points. So, and they're going to be as many as these. So you're going to say private vector 3 vector 3 or array side ray origins. Origins. Semicolon. Origines. This is Spanish. Origines. Save. Side array origins. Okay, so one thing that we're gonna do is we're gonna set up those arrays in start, and we're gonna create a function for that. So we're gonna go void setup side arrays. Okay, save. We're gonna call it in start. Call it here. Yeah, there it is. It's there, it's there, it's there. It's been there for a month. Open, close round. Semicolon. Alright. So when we set them up, the thing that we need to do is we need to create this array. So why is it an array, in your opinion?
Because there are multiple sides?
No. Good guess, but no. We're gonna move them depending on where you're going. Unless later we decide to in fact have them on both sides, we'll see. But no, the reason why there are multiple arrays is because we're gonna need more than one. Right now we only have one down for grounded. That's a bad idea. We're gonna need more of them. That's because you may be grounded on the tip of something. Let me demonstrate to you the problem. We can already see it in game. So right now, you are grounded. Now you are. Now you aren't. Did you see that?
Mm-hmm.
Now you're not grounded. The only reason why you're staying here is due to the collider. But are you staying still?
No, because the transfer moves.
That's right. The transfer is moving ever so slightly, and you're eventually going to fall off.
It.
Okay, so that's not what we want. We want precision. So we'll worry about it later. But for now, all I'm saying is we're going to need more than one ray. Okay, because otherwise it would just shoot from the center, and it's going to look really, really weird, because only if that ray hits, then our calculation is going to work. We need multiple ones. So in order to do multiple ones, we need to know a few things. We need to know how tall our character is. We need to know where to start, etc., etc. Anyway, one thing that I want to do, that I've been wanting to do for a while, well, since last time, is I want to modify our player a bit. So our player, let's go to the scene view here. Our player over here, its pivot center, its pivot is right here. I'm going to change that. I'm going to put it under his feet. So I'm going to grab the model and put it here. Now the player's pivot is here. Now I'm going to put the collider up. So this should work exactly the same, but the pivot is at the bottom.
The ray is longer.
Yeah, one thing has changed. The ray is longer. And the reason why the ray is longer is because, and now stuff is broken a bit because of that. The reason why the ray is longer is because its origin point was at the center. Problem is the center is now at the bottom. So we need to actually change the way the grounded ray shoots down a little bit. We're gonna need the height of our player stored as a serialized field. So we are going to put it where? Let's see here for now. So serialized field. You forgot the square bracket.
Oops.
Hit tab first and then put the square brackets. Too late. Serialized field. Close the square bracket. Private float. Yeah, actually make a private vector 2. Yeah, vector 2. And call this one player sizes, or player size. Size, and go equals new vector 2. Open round. So on the x we are 1, so 1f, comma, on the y we're 2f. 2f. Close the round, semicolon. Save. Okay, so this is how big our player is. So now we can use that. In check for grounded, instead of transform.position, we're going to say transform.position plus vector3.up dot up times times player size dot y but half of it, so divided by 2f. Save. So what is this? I'm taking the origin point, which would be my pivot, which is now at the bottom of my feet. I'm pushing it up by 1 point, multiplied by 2 in this case, so by 2, divided by 2, so 1. So that should already work. Because we're using ground ray origin, should be correct. So whoops, I went to OBS. Okay, so let's take a look. There, the ray is back to being what we wanted. Perfect. Now let's create those rays on the sides. So for the rays, this one almost certainly needs to be 0.6 because it's only half of the same distance. It would be more intelligent to actually calculate those, but whatever, we'll worry about that later. So rays, first of all, let's add another variable here, which are going to be serialized field private int, and call this one side ray density. Density means how many there are in a certain amount of space. Go equals, and let's say 5 for now. 5 semicolon. So from our side, we will be shooting out 5 rays. Okay. So here, you're going to say side rays. Copy this, paste, equals new ray. Open square bracket. Density. Density, add a few letters. There it is. Close the square bracket. Semicolon. Copy this. Paste. Paste. Save. Copy side hits. Paste here. Raycast hit. Raycast hit. There it is. And copy this. Paste it here. Vector 3.
Oops.
Undo, you'll be much faster. Too late now. Vector 3. Okay. Save. So now we've initialized all of them. The side ray origins can actually be calculated right away, and we will do precisely that. So here you're going to say for int I blah 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 blah. I needs to be lower than side ray density. Lower, not higher. Yeah. I++, close, open. So in this loop, what we're going to do is we're going to actually create all of the starting points for all of the rays. Now we need to think this through. The starting point, the first one, can start on the ground, but I suspect it's going to be a little bit too close to the ground. So what we're going to do is we're going to add some padding. Do you know what padding means?
No.
That we're going to add some space from the ground and from the top. We're going to squish the rays together just a little bit.
Okay.
Okay. So in order to do that, we need another variable. Yoop-de-doo. Copy this. Paste it here. Type padding, P-A-D-D-I-N-G. Padding. And put 0.1. Save. Okay. So what we're going to do this is we need to figure out the math behind this. So let's start by writing side ray origins 0. Not 0, but my bad, but I. Square bracket I. Equals. And here you go, vector 3 dot up. That's correct for sure. Vector 3 dot up. Times. And that's where the big boys happen. So we're gonna have to multiply this by I, float I, cast it as a float I, divided by float density, cast it, density, yep, that's the one, tab, Okay, so let's think this through. Side ray density is 5. I is going to be 0. 0 divided by 5 makes?
0 divided by 5 makes...
0 divided by your mom makes?
0.
Well done. So 0 divided by 5 is 0. Then let's say we get 1. That one is going to be at 0.2. Then the next one is going to be 2. 2 divided by 5
is
0.4. 3, and so on. But we're never going to get to 1. So that's going to be an issue. So what you want to do is you want to open a round bracket here and go divided by, rather minus 1. Because we're never going to get to that point otherwise. Okay, save. So in practice it ends up being a 4. Wait, am I being dumb? I think so. I think I'm being dumb. No, ray density 5. 5 minus 1, so 4, 5. Yeah, because we can never get to the 1 otherwise. I think this is correct. But it will end up doing 1 less ray that we want to. Well, let's see how it goes. I may be dumb here, I'm not sure. Okay, but we're missing the padding. And the padding isn't that easy, because if you put it just from the ground, then you're going to get everything moved up too much. And so that's not going to work for us. We're going to have to add the padding somewhere. And the way we will do it is by adding the padding divided by the density. So you go plus, actually that possibly, yeah, that should work. That should work. Okay, put a bracket over here, plus padding, yeah, and this one's gonna be divided by side density to this, copy this, paste, close round, semicolon, save. Okay, so I'm not sure this is going to work, but it may. Now, here we have check grounded. We're gonna create another one called void check sides. Check sides. Open rank, yeah, exactly. So for now what we're going to do, the only thing we're going to do is we're going to create the rays, just like we did this one. So let's copy ground ray, copy, paste it here, here, yeah. Now, but we're also gonna need the loop. So let's copy the entire loop here, paste, okay. Now cut this, paste it here. Now here you want to have side rays 1 or 0, I, side rays I, where is it? Side rays I equals new ray transform dot position, that's correct, plus we're going to need the origin. This, copy this, paste it here, and you go dot not dot, but rather I. Okay, save. And now for the vector down here, I've just realized my padding is calculated wrong. I'll have to worry about it later. So down is wrong. It needs to go either right or left. So for now we're going to cheat and just put right. Yeah, save. Okay, yeah, save. Now here we're gonna copy this bit.
Oops.
Copy this bit. No, wrong place. Undo.
I haven't done anything.
Undo. I have. Okay, paste. Close. Shift tab. Okay. So if physics raycast, not ground ray, but side rays 1, copy this. Paste here. Side hits 1. I. Side hits I. Side ray length. 2 down. Tab. Okay, save. And now we are going to use the debug draw array just as we did last time. So copy this. We're not going to do anything other than debug draw array. Yeah, paste. Else. Open squiggly, enter, close it. Save. Okay, draw array, not ground array, but side arrays. So copy this, paste it here, paste it here, and copy this, paste it here. Copy all of this, paste it here. Red. Save. Many spaces.
Whoa, oops.
Save. Okay, so what this does is it just draws those debugs to see what the situation is. I bet you we got the formula wrong a little bit, because I'm fairly sure I did. Where was it? Okay, so check sides. We're gonna call it in update. Right here, check sides. One down, open, close, semicolon. So, all right, so let's see what the situation is here. Okay, there they are. You can see our arrays.
Yes.
They are spaced sort of correctly, but what are they not accounted for?
The height?
That's right. They're not accounting for the height, so that's a problem. We need to multiply by the height. So let's go take a look. This is in origins. That's where we're worrying about things. So it says vector up, that's fine. Side array density, that's fine. But all of this needs to be also multiplied by the height. So copy player size. Put a big multiply right here. Paste it. .y. Save. Okay, fairly sure it's still wrong, but it's going to be a bit better. Da-da-da-da. There they are. Okay, now let's take a look what's wrong. You should be able to see what's happening with the padding. So the padding is pushing everything too high up, right? The padding isn't in fact helping the squishing at the top and at the bottom. And I've done this before, but I haven't done it in a long time. So my brain seems to be not ready to learn this, at least, or to think about this, at least at the moment. So let's quickly check if, see they're turning green?
Mm-hmm. And they're not sticking to,
But yes, it is, when you push. But we haven't done anything about that yet, right? So, but at least they're turning green. So they are detecting, dude, you're hitting something, right? So we can make you slide down or something like that. Okay, so that's working. There you go. You can see them do their job. Okay, now we need to fix that padding. So let me think this through. Plus side padding times the density divided by 1. That makes no sense because it doesn't use the loop. So it needs to add itself and then subtract itself somehow. I'm wondering if we can remove the padding from here. That may already help. So copy this, put a minus, paste it, close it, save. Let's see what happens if we do this. This should already help us with not reaching our top. Okay, yeah, something's definitely helping. Still not perfect. Oh no, yeah, done. See, it's padding by that much and this much. Although I think that it's a bit of cheaty because it's not really padding by as much as I requested. I'm fairly sure the 0. But I don't know, man. Is this 10% of this? I'm really not sure. Well, we can find out actually. Let's move the model up by 0.1. No, it isn't. It's less than that. And I'm not surprised. Okay, anyway, doesn't particularly matter. We're fine with this, even if the math isn't super perfect. Okay, so how much time do we have? Just a little bit. So let's do something first to try if we can make this work properly. So the moment in which these at least one of these hits, we should have a boolean that says, hey man, you're hitting in the side. So what we should do is we should figure out how far the side is from our character. Okay. And if it's closer than a certain distance, we completely turn off input. We could just generally lower it, but it's probably a bad idea. So we're just going to turn it off if the distance between whatever we hit is there. So let's do this boolean. Okay, we stop the code here. So can jump ground. Let's create another one here. Let's make it public so we can see it. So go public bool. Actually, make it an int. So we're gonna have 0 for nothing, 1 to the right, -1 to the left. So in, and you go side obstacle. Side obstacle. I missed the T. Obstacle. Found. Put a found. Semicolon. Actually, probably better to call it direction. That would make sense. Direction. Yeah. Save. 2 semicolons. You want to be absolutely sure that that line of code has stopped. All right. So in here, in check sides, if we hit something and therefore we go green, we're gonna say that the side obstacle, at least for now, is to the right. Okay. So we're gonna say side obstacle equals 1. Side obstacle direction, there it is, equals 1, semicolon, save. And what do we need to do? We need to return here. We're gonna have to exit. Or what we can do, even better, is copy all of this, paste it here, give it a value of 0, okay? And here we're gonna say if open round, side obstacle direction equals 0. So copy this, paste, equals 0. Close round, open squiggly, wait, all right, sure, close it. Cut this, paste it here. Okay, so it's only gonna change once, save, and then it's not gonna change again. Okay, because if it's 1 or -1, it will leave it alone. And copy this. And no, actually this you can leave alone. Okay, save. So the side obstacle is going to go to 1 or to 0. So let's go and take a look if our thing is working. Keep an eye out on the inspector, right? Side obstacle direction is 0 at the moment. Okay, so still 0. Watch now. 1, 0. 1, 0. 1, 0. Okay, now we have that 1, correct? So we can now use that information to check the distance. And but we should do it in here. So perhaps this was a bad idea after all. Yeah, this was a bad idea after all. Well, anyway, the rays are too long. So perhaps if we just make the rays a little shorter, it'll already help us. So where is it? Side ray length? 0.6. Why does 0.6 make sense? Yeah, why does it make sense? Or 0.7? How fat is this character? Hello?
I need to check.
What do you mean you need to check?
How fat the character is.
Well, we've talked about it before too. You can't find that information. The scale is 111. How fat is it in terms of how many blocks would it take? How tall is it? You remember that?
It's... no.
2. Player size. It's 1. Okay, so it's fat by 1. So why is 0. something more than 0.5 sufficient to get outside of the body?
Because 0.5 will be half.
That's right. So 0.7, we're going to put it there. Okay, side ray length, 0.7. Okay, let's actually go change the default value. Oh, wait a moment. What is the default value? Oh, 6. Well, 7. Save. And what we're going to do now is we're going to say if side obstacle direction is 1, ignore the input. That's what we'll do. So where's the input? Update, blah, 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 input. Oh, we need to store this input first. Okay, so let's create a private vector2 vectop. vector 2 movement input. Semicolon. Copy it. Paste it here. Equals new vector 2. Open round. Copy this. Paste it here. Comma. Paste it again. Type vertical. Vertical. Close the round. Semicolon. Copy this. Paste it here. Dot X. Save. So movement input X dot speed. So now we have the movement input, and now we can manipulate it. And we're gonna say if, and you're gonna say side obstacle direction higher than 0. Zero, close, open squiggly, enter, enter, close squiggly, close squiggly, copy, paste, dot X equals 0. F. Try again. 0. Save. So this now only works for the right direction. We need to do the left as well, but let's see if it works. So now this should let us just slide down the wall. It's correct. Yeah. But you will notice that sometimes he'll be a little bit further from the wall than he should be. That's because we're not doing anything particularly clever. Okay, we should do something cleverer than this. Now the reason why this is happening is because it's turning off input when those rays go green. That's why you see them go green, and then he collapses down. Okay, and you see how important it is to have a high density. Let me show you what a low density would look like. So let's say a density of rays of 2. Okay, and now we're gonna have one top and one bottom, and they're wrong, by the way. Yeah, I thought so. I definitely have that math still wrong. Why am I still stuck?
Because there's not enough rays in the middle.
That's right. There's not enough rays in the middle, so we need to have a few more. Now 5 seem to magically work, but it's pure luck. Actually, maybe it isn't. Maybe all odd numbers would work. I'm not sure. No, even this one's wrong. Yeah, the padding is definitely bonkers. Pure luck that it works with 5. If I put 7, I always want to have a middle ray. That's why I like to do that. Yeah, see, it's wrong. Now it's further down than up. We need to fix that math. Okay, now let's see. Whoop. All right, it's working. Da-da-da-da. I think this is a good note to end it on today. There he works. There, you try it. It only works on the right for now, but it's fine. We'll fix it on both sides next time. On the left, try it. I'm sure you're gonna get stuck. Ha! Spider-Man!
Right here.
Right here. Slidey Man. Soap Man.
Oops. Fail man.
You're a bit bad at this, eh? Come on. Go test it.
Ah. Not this side.
There you go. Working. Sliding up, sliding down, no problem. No problem. Alright, peeps. We'll be done for today. This has been Mike and Zoe, and we will see you again next time where we fix some math and set it up so the left side works too. Thanks very much for watching. Bye-bye.
Bye.